Welcome guys to GDEX Academy. And we have measure of location for you guys today. So what is measure of location? It is a summary statistic which is concerned with a figure which represents a series of value. Measures of location can be further classified into two, which is measure of central tendency or measure of average and measure of partition. So we'll be discussing measure of central tendency for this class, then we'll be discussing measure of partition when next we meet. So what is measure of central tendency? In average measure of central tendency, there is an average value which is representative of all the values in a group of data. This typical value of average tends to lie centrally within the set of data arranged in an array. Hence, they are called measure of central tendency. Is subdivided, can be categorized into this. We have the mean, mode, and median. But under that mean, we have arithmetic mean, geometric mean, and harmonic mean. So I'll make sure I touch each and every one of it in this class. And then we're going to mode and median. Thank you. So as for the arithmetic mean, it is the sum of all values in a data group divided by the total number of the values. Therefore, the formula for it is an arithmetic mean. It's equals to summation of x over n, because the summation of the total value divided by the total number of the value. This is for arithmetic mean. We are discussing arithmetic mean here. This is for this formula here. This one represents the formula for group data. So these are why the sign, the symbol for that looks like A represents the summation symbol, the sum of frequency and the data summation. Then N represents the number of values. Then the F here represents the frequency. Example for the class. We are told from the unlisted data generated on the number of sales of cement in bags. This is the data. Then you determine the mean. So I forgot to tell you earlier that arithmetic mean is usually known as mean. So whenever I see determine the mean, you should know that it is arithmetic mean. Therefore, this is an ungroup data. Therefore, this is the formula you have to use thus. Summation of x over n. So x represents the data, like I said earlier. Therefore, this is the symbol for our mean. It's equal to the sum of all this. That's 12 plus 7 plus 2 plus 6 plus 13 plus 17 plus 14 plus 5 plus 9 plus 4 divided by total number of divided by. So therefore our arithmetic means because when you sum up this you get 89 divided by 10, which is equals to 8.9 bags. So once you approximate it, therefore our answer is 9 bags. Our answer is 9 bags. So as you can see, it is as simple as this. And suppose to like and subscribe for a grouped data. Thank you. We are told that the table below contains the data collected on the number of students that registered for direct entry at some examination centers. Obtain the mean, of course, the arithmetic mean. So this is the data here, x1827. So this is a group data, and note the formula for solving this is quite different from the ungroup data. Alright guys, this is the formula for an ungroup data for an arithmetic mean. So it says summation fx, so we have to get our fx first. So these are, let's get our fx. This, you multiply f by x for us to get fx. This 8, this 14, 3 times 10, 30, 6 times 4, 24, 5 times 2, 10. So over summation f. So once you sum it up, you get the summation of it. You sum this up, okay? Once you do that, you have 86 here. Once you sum this up, you get 86. Then as for here, you get 33. So your answer here is equals to 86 divided by 33. Therefore, we have, if you should divide this by both, we have
Alright, so that's
2.6061 our mean for that. So I'm sure you guys must have been expecting me to give you guys a question on this, having the class limit. So when you are faced with a question like this, the first thing is to do, you are going to look for the class midpoint. And how do we get that? You add the lower class limit plus the upper class limit, then you divide it by 2. So let's do that really fast. 10 plus 0 is what? 10 divided by 2, 5. 10 plus 20 is 30. 30 divided by 2 is 15. 20 plus 30, 50, that is 25. Divided by 2, you get 25. This is 70. You divide by 2, you get 35.
Then our next step here is
to write our frequency. 776. That's our F. Then I look for our Fx. That's 12 times 5. That will give us 60. 15 times 8 will give us 120. 25 times 7 will give us 175. 7 times 25 will give us 245. 45 times 6 will give us 270. That's all. Then you sum it up. When you sum up all of this, you have 40. That's our summation F. Then for our summation Fx, we have 870. Therefore, you put in our arithmetic mean, summation Fx over summation F. So our summation Fx is 870. Our summation F is 40. So we have 21.75 years. That's our mean. So whenever I see a question like this, just convert it to our class midpoint, which represent our x. Look for your frequency and you get. Alright, so here is our geometric mean. This is our formula for geometric mean. N in the root of product of x, which is the data. N represents the total number of the numbers and total numbers of the value, while x represents the data. But for using example 1, for the ungrouped data, we use it to get our geometric mean. So our geometric mean is equals to 10 12 times 7 times 2 times 6 times 13 times 17 times 14 times 5 times 9 and times 4. Therefore, once you find the product of this, you will get this. Then 10 root this. Therefore, our geometric mean is 7.4977. So that is all about mean for today. Then what we have next is our mode. This is the second section for this class, which is the mode and the median. So we'll be starting with the mode first. The mode is the value which occurs most frequently in a set of data. For a data set in which no measure values are repeated, there is no mode. Otherwise, a distribution can have one mode, that is unimodal, two modes, which is known as bimodal, or many mode, which is known as multimodal, depending on the data set. For a group data with frequency distribution, the mode is determined by either graphical method through the use of histogram or the use of formula. But for this class, we'll be solving the mode using formula. Then by the formula method, this is the formula for the mode. Lower class boundary plus, in brackets, the modal class frequency minus the frequency. Modal class frequency minus frequency of the class after the modal class. Then the CD represents the modal class size. Then for the median of a set of data is the value of the middle item of the data when all the items in the data set are arranged in an array form, either ascending or descending order. For an ungrouped data, the position of median is located by n plus 2 divided by 1. That is for an ungrouped data. While in a group data, the position for median is located by n/2. Here, the specific value of median is determined by either the graphical method through the use of OGIF or cumulative frequency curve, or the use of formula. So like I said, I'm using formula to solve each and every one of the question here for this class. For median, it's quite similar to that of mode. Just a few differences. It's just that we make use of frequency here instead of the modal class. So we have the lower class boundary, and the total number of sets, total number of items in the data set. The bigger F there represents the cumulative frequency before the median class, which is this. Then the F there represents the frequency of the median class. Then C, the class size, the median class size. So the question for today is, we start with an ungrouped data as usual. This is the set of data. I thought to calculate the mode and the median. So for an ungrouped data like this, the mode should be very easier. So what is the highest occurrence of number here? By having a look at it, 3 appears to be the highest. So our mode here is 3. Then for our median, that is our formula for an ungrouped data is n plus 1 divided by 2. So this, the other formula shown above is this for a group data. Then the first step in solving a median question is to put the data in an array, in an order, you arrange it. So once you arrange it, you rearrange. 1 comes first, then 2, then we have how many? 3. Then we have 4, we have 5, 6, 7, and 12. Because this is an ungrouped data, therefore you count it 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Our n here is 11. Our total number of items, which is the n here, is 11 plus 1 divided by 2, which is 12 divided by 2, because 6th position. So our 6th position here is 1, 2, 3, 4, 5, 6. Therefore, our median here is what? 3. The median is equal to 3. You can also count it using our ordering method. 2, 3, 4, 5. So we are still left with 3. This is our middle. Therefore, notice that n is odd. So I came up with another question, making n even. So I added the 4 to the other question. Therefore, as usual, our first step is to rearrange it. 3, 3, 3. We have 2, 4. Then 5, 6, 7, and 12. So that's what we have here. Then our total number here is what? Our n here is 12. Even. Right, the other one is 11. So this is what we do when it comes to a situation like this. And note our median is n plus 1 divided by 2, which is 12 plus 1 divided by 2, which goes to 13 over 2. 6.5 position. So 6.5 is in between 3 and 4. You know that it is in 6.5 position, which is in between 3 and 4. What you do is you bring out these 2, which is 3 plus 4. Then you divide it by 2, which is 7 divided by 2 is equal to 3.5. Therefore, our median is 3.5. Our median is 3.5. Alright guys, so we have a question. I have a question for you guys, which is group data using formula. So this is the formula. The following are the data generated on sales of electric components. We have class interval, frequency, and if you guys should remember what we did on mean, first thing is to look for your class midpoint. So 2 plus 4 is 6. 6 divided by 2 is 3. This is 10, which is 5. 14, which is 7. 18, which is 9. So these are our class mark, which represent our x. Then you write your frequency. 3, 4, 6, 7, 2. Note, we are looking for our mode and median. So the highest occurrence here automatically is 7. So this is our modal class. 7 is our modal class. Then we use our cumulative frequency to get our median. For our cumulative frequency, we have our 3, 7, we have 13, 30%, we have 20, then 22. And note, for us to look for our median, for grouped frequencies, n over 2, and n is what? 22. This goes to 11. So 11 falls under what? 13. Therefore, this is our median class. This is our median, this is our mode. Alright, so the next step is to look for the formula. Put our formula for mode plus our L1 here. This is our modal class, so our L1 here is what? 8. Then triangle 1 is what? 7 minus 6. If you remember the formula. Frequency of the modal class minus frequency below, that is 7 minus 6 equals to 1. Then for the after, which is equals to 5. Then our C, which is class size, 2. Therefore, we can now slot in the formula. Our mode is equals to L1, which is 8, plus 1 over 1 plus 5, 2. See? So this is 1 over 6. One over 6 in brackets 2. So if you multiply this, we have 8 plus 1 over 3. That will be 8 plus 0.3333. Therefore, our mode is 8.33. So we have gotten our mode. Our next step is our median. So we put our formula for median, which is L1 plus n over 2 minus bigger f. Then we have a smaller f, then C. So we already gotten n over 2, which is what? 11. So we write our L1. Going back to the formula here. So for our L1 here is what? 6. You write it down. Then our n over 2 is 11. Our bigger f is what? Sum of the cumulative frequencies before the median class, which is what? 7. 4 plus 3 is 7.